Hello everyone, today I'll be making a video going over JavaDocs and best coding practices. JavaDocs is where you can find many of the Java methods and functions and imports, and best coding practices will just help make your code more efficient, readable, and easy to scale. So to start, I want to give a brief explanation of what JavaDocs is. JavaDocs is the website that hopefully you guys have heard of and seen before that shows all of Java's documentation where you can go to look at the Java API. So for example, if I'm looking for just an explanation of what a string is, JavaDocs has tutorials, has information regarding all of the important things about strings, and it's a very useful tool for developers. JavaDocs is a good resource to use if you're ever looking for a way to make your projects more complex, or if there's something that you're told to use and you don't know exactly how to. So, for example, we have strings here. JavaDocs tells us how we create strings, and since a string is an object, it explains what the string is made up of, and then it uses some examples of string methods such as length, gives us some examples on how to use strings, and overall just gives us a good explanation of how we can use this element. The next example of using the API that we'll go through is just looking at this iterator. So Java API, we searched up iterator just in the search box, and we can see what package the iterator is in. So this is, if we want to use iterator, it shows us what we need to import. It shows us the different sub interfaces. So like, say you have an array list or a linked list, it would show that a sub interface of linked list would be a queue. So here it shows different methods that iterator has next, remove. You all have seen that before. And then it shows you how you can use each. So implementation of has next just gives you examples of all of the methods. You can find the JavaDocs at this URL. You can also just navigate to the Oracle webpage and they'll have documentation available. This is where you can find all of the JavaDocs information. This is kind of like the main web page that links all of the sub interfaces. If we want to navigate java.util is the one that we most commonly use, so we'll navigate there. This is in Java base. Then we scroll down. It has all of these, including java.lang, java.math. So we scroll down java.util, and we can see all of the different classes and interfaces we have here. So we have arrays, enumeration, formatting, hash sets, hash maps, iterables. So this is where a good resource to go for information about specific topics if you're ever confused is. Understanding the information here can be a little more complex. If you're ever confused, definitely look into the specific page, look at how they use the examples, what the methods are, how they use the methods, and then you can always go further and Google specific use cases of each of the methods and interfaces if you need. Another useful thing with JavaDocs is it's a tool that you can use to explain your code and make it more readable for others and for yourself. So JavaDoc comments are comments that you add to your code and methods explaining the purpose of your code. So for example, we see here that there's a method that returns an image named getImage, passes into variables, and then has its functionality. And Java.comments explain the purpose of the function outside of the function. So here we see what the main purpose of it is. Okay, it returns an image object that can be painted onto the screen. This method returns immediately. And then we see here param. This is the first parameter, which is URL. And then it gives an explanation of the parameter. Parameter name, an explanation of the name, what it returns, and then any other classes or objects to reference to understand the method better. So this is a good example, but we'll jump into a practical example of this that might be a little more readable. So here I have just an empty, or just a class, an example class, and to create a java.comment, we're going to use this /**. So to make it /**, and I'm in VS Code right now, which is what JavaDocs has the built-in shell for all of our individual assignments and labs in there. So here it shows up with java.comment. We can just go in here. Anytime you create a return, it should add a little asterisk. However, if it doesn't, it's standard practice to add an asterisk for each line. And that's basically how you create one. They're pretty simple. So we see here this is all possible bindings for the java.comment. So param is the parameter. Return is what we're returning. Exception or throws is whatever exception or throws we might have in the method. C is links to another element in the documentation. Since is explaining a date. Most of you probably won't use this, but this comes in higher development. Version marks the version of a method or class. Deprecated indicates whether it's usable or not. So sometimes programmers will have a method that goes away or changes and it's not usable anymore, so you can mark that. Author, who wrote it. Link, any data or web pages that you might need. This is just a link to the JavaDoc. And then code gives code examples within the comments. And then inherit doc is deprecated, I'm pretty sure, but it shows if you inherit the comments from the superclass, so other methods. And then here we have the method, just example method, and then the one parameter up here. So this is an example of how a real comment might look using all parameters. Obviously, it's not suggested to use every single parameter. Usually you just use parameter, and then return or throws. It's not standard practice to kind of use all of these, but in higher level programming, it is useful to add versions and then deprecated and then other code references. But so we see here parameter 1, loan amount, parameter 2, total payments, parameter 3, annual interest rate, and we describe each one here. And at the beginning of your JavaDoc, you want to explain the function of the method or class. So here we say that this method is going to calculate the monthly payment of a given loan. So that's what this method is for. And then all of the information here. So that's a brief overview. Next, we're going to kind of move into a little more readable and standard practice. So this is just a basic calculator. And now we're kind of getting more into the essential coding practices or best coding practices. Java.comments are one of them. So that's a good transition spot. So here is explaining the add. Obviously, this is a simple example. Most of the time you wouldn't need an explanation for an add, but we'll go into better examples later on. So parameter 1, numbers, returns, number 1 and number 2. Simple. Same thing with subtract. Then in the divide method, we also throw an illegal argument exception if number is 0. So this is just a simple example of ways to use java.comments. So now we're going to be going into best coding practices. it's important that we have good coding fundamentals and practices so we can make our code more readable. We'll be able to change it better, we'll be able to scale it better, and it should be more efficient and secure. So this is just a class named test. Pretty basic example. It just does some string mutation, uses some array lists, does some basic math with methods, and we'll kind of be making this more efficient and reviewing it and fixing maybe some warnings or things that might not make it the best code that we can create, not the most efficient. So the first thing here is we import java.util, and we import the entire java.util library. If we go to our JavaDocs, we can see in the java.util, we have all these methods and interfaces that we're importing. And a lot of times for smaller projects, it doesn't matter if you import everything. However, once you get to larger projects where runtime and size matters, importing the entire library can add an unnecessary strain on the system. So first thing for here is we don't want to import everything. Say if we're just using array lists like we are in this example, we can just import java.util.arrayLists. And then we have all the functionality we need without importing the entire class or entire interfaces. The next thing that we should look at is the name of this class. So this one's just named test. Sometimes you might just create a test class and name it test and then actually build your entire project in that class, and that's not good practice either because we don't really know what this class does from the name. So as we can see here, it has some strings and it has some numbers, so we can just name it something different. We can name it like number adder, and then that's a good enough name that we have right now. The next thing that we'll see here is the array list. So currently we're just declaring an empty array list, but we don't define what type of array list it is. So array lists can be objects, they can be strings, they can be integers, but it's good practice to declare what type of array list they're going to be. In this case, we're adding numbers to it, so we're going to declare it as an integer array list. This is going to just tell the computer that, hey, this is only going to have numbers in it. Then we see some of those warnings go away, and in Visual Studio and a lot of modern IDEs, it'll give you those warnings for stuff like that you can fix. Next, we see here, we have this string that we're formatting. This is fine by itself. However, say we had like 5 different variables that we were putting into a string, we would want to use a format method to clear that up and make it a little more usable. So like here, I'm passing in 2 integers. It's a lot cleaner just to have the integers passed in here so we can see them. Next is we have some methods here. This is a method that by the name we don't really know what it does. So here we can see that it adds, but if this method had like 50 lines of code, it wouldn't really be time efficient to go through the entire thing to figure out what it does ourselves, when we can just change the name. So we could change this to like add numbers, and then that gives us an explanation of what the method is going to do. The last thing on this class is double negatives. A lot of times we'll name variables like is not negative or is not true or is not there. Anything like that that is a double negative we shouldn't use because it can get confusing just like trying to reference it. It's just another mental step that we don't need to add and that we shouldn't worry about. So we can change this to is positive, and that gets rid of the negative, double negative. So now if it's positive, it'll be true. If it's negative, it'll be false. So trying to get rid of double negatives as much as you can is really important. Okay, now making all these changes, we can define new types, we have better names, We only use the imports that we need. For adding strings, we format them correctly, and then we can also add in our JavaDocs to explain the methods better, even if they're simple. Sometimes it's nice to add them, but definitely when you have more complex methods, it's really important to add. We are going to look at nested if statements. So this is just an example. It's a very messy example, but sometimes code can get like this, where you have 6 indentations till you get to the line that you want. And this can get really, really confusing to look at, and it can make formatting your code really difficult. And if you mess up just one curly brace, it could give you an error. And that's just something that we don't really want to deal with when it's not really required. So because there's so many if statements, we want to kind of reduce the amount that we have. One way to do this is by using early exit programming, which is basically when you have a condition with an if statement and it's going to return, you want to return it as soon as possible. You want to kind of expand all these if statements and make them shorter so they're not all nested inside of each other. So we have this example method here, Java comment, and what we'll see here is none of our ifs are nested. It's a lot more readable, and it'll be easier for us to debug it and just make sure that everything works good. So we'll notice that we broke down all of the if statements and returned them as each line goes through. So if we don't have an order, then we just return it right away, which is what's right here, except we break out the else and make the else the conditional. So it's kind of, in essence, doing a negative of your if. So before we add if order is not null, then do this, else do this. What we should do is just get rid of the else. What we should do is get rid of the else and instead make that what we want to do. So that way we can just return here. And you'll notice that it makes our code a lot more readable. It'll be easier to debug and just fix overall. And then we know as we go down, each kind of like check that we have to do is completed. So at the end, we know for sure what the condition is. This does require us to know like what our target is and not just like leave empty space for code to filter through, which we wouldn't want anyway. We want to make sure that all the data that goes in there, we know exactly what it is and have a return case for every possible combination of it. Another name for this practice is guard clauses. So we'll see here that we have all of this stacked in here. If user is not equal to null, then we do something, and then check if they have a loyalty card, then do something. Then if their user purchase count is greater than 10, then do something. Instead, we can break it down and make it shorter. So we see here, if user equals null, then we just return right away. If the user doesn't have a loyalty card, then we just return right away. If the user purchase count is less than 10, then we return. And we can see that we got all the checks that we want, but with much less nesting, no nesting. And then one way to make this even more efficient is by putting all of those into one if statement. So now all 3 of these checks, this might not be true of all cases, but in this case, we can do all the checks at once. One way that this is even more efficient is by using what Java and other languages we reference as short circuit evaluation. So this basically makes it so if we have a bunch of conditionals that are connected, if one of the cases causes us to be true or false regardless, then we just do that anyway. So for example, in here we have if user equals null and not user has loyalty card and user purchase count is less than or equal to 10. So if any of these are false, it'll just continue without checking. But if it goes through all of them, then it will return. So like if the user exists, it won't even bother checking these 2. So that reduces the strain on the computer and just makes us have faster programming overall. One more example of efficient coding practices is making sure our names are good. So here we just have level. That's not very informative to kind of like what we're getting at. We see here that, it defines what access level the user has, but we don't want to have to go through the code to read it to see what this is. Another thing is S is a string, which is an object, so we really should be using the .equals method. So here is a better version of this method. We have a better name explaining what it does. We explain what variables we should input instead of just having our variable named S. We return, and then inside the return we have a switch statement. The switch statement takes in the count type and checks in each case. Switch statements are most of the time faster than if statements. That's another thing to go into, but in cases where you have data like this, using switches are a lot easier to read and more efficient. And then here we have something that we call a class member access operator. This is basically just going to put this number and put it in front of the return, so we don't have to add a return statement before every single one of the numbers. And that's just going to make our code overall faster, easier to read, and more accessible. Putting all of these kind of like programming practices into use, we can look at our an upcoming individual assignment. So we'll start with 29.1 MyStack. So here our point, what we're trying to do is finish this public class named MyStack. We're implementing iStack's interfaces. We must implement it as a linked list or array list. Can't be fixed to any size. And here we have a bunch of methods. So what we're going to be doing here is writing JavaDocs comments explaining all the methods and what we expect in each one of them. So here we have a definition of all of our methods. We have public method, they're all public. We have push, pop, peek, index of, size, and is empty. And they give us what parameters we're going to do in between each one. I like to copy it here so I can just put it in my code and not have to go back and forth. But we'll delete that later. So to put in some JavaDocs comments, we'll add this. You guys probably have this in Visual Studios. But so this is the JavaDocs format. At the top, we're going to put an explanation of the method. We can actually just copy what the program gives us and put it in there, because that's exactly what we want it to do. We see from here that it's named push, and then it takes in an object. So we have a parameter named item. You see the name here. So we have the parameter named item, and the item is going to be an object to push on the top of the stack. So just give an explanation what it is, and then we don't return anything, so we don't need to add a return. And this is good enough for what we want. You don't need to like say that we're returning nothing. So that's what we'll do for the push. For the pop, we're going to copy the method instructions here. We'll put it as the top explanation for the method. We see that public method named pop that takes no arguments and returns an object. So here we don't have any parameters, and we're just going to do returns. And what we're returning is the top of the stack. Returns the object at the top of the stack. And then we also might want to signify that, hey, when we pop, we're also going to delete. So a public method named pop that takes no argument and returns an object, deleting the object from the stack. And you can always add an indentation to make it a little more readable. So that's our pop method. For peek, what we're doing is we're going to be looking just at the top and returning it without deleting it. We should actually rename these because the instructions don't exactly define the method well. So for the push, we don't need to signify that we're returning nothing because that would be in our Java comments. Here, pop takes no arguments and returns the object at the top of the stack. And deletes it from the stack. And then peek, name peek that returns the object at the top of the stack, and then doesn't delete it, but we don't need to add that. And it returns the top object in the stack. Next we have index of. This method is going to take in a object and we're going to find the location of it and return that. So we get the name, what its function, the index position of So here our parameters are item, and we return an int. So returning the index of the object. We return -1 if not found. And then item, so that's our index of. Next we have size. This method is going to return the size of the stack. So here we're just returning the number of elements in the stack. Next, or finally, is Boolean is empty. Return true if the stack is empty. And here it's pretty simple, so we'll just repeat it. So that is a basic example of how we can use Java.comments to explain what our functions are doing and what our code is supposed to do, and just make it a little bit easier on us for programming it. Now we've defined exactly what type of methods we want to add, the functionality of it, and we can stay to that and just have a game plan for that overall. Thank you all for watching. I hope this helps explain some important coding processes, and I hope it makes your code a little bit more efficient and easy to read. I would recommend using all of it in your labs and individual assignments and get used to those good coding practices. Thank you for watching. Bye.